Hello, I'm Rebecca the Maths Lady, and welcome to this video which is all about how we can use poppits to support our children who are experiencing the most profound difficulties with learning maths. Now, I would not be able to count the number of times people have asked me for a step-by-step scheme and process for sorting out the problems of the children who struggle most. The problem with creating such a scheme is that children are not machines. Many of them are incredibly stressed and broken by the experiences they've had in failing to learn maths. And they've got all sorts of psychological and emotional barriers to learning. 12 years ago, I was resourced to work on the English National website for teaching assistants working with children on their maths. And one of the clearest learnings we had from the process of developing that website was that people working with these children need to expect to experience repeated failure. There isn't one particular method that works above other methods. You need to have lots of strings to your bow, lots of ways of doing things, because if a child has all their barriers up, they are going to defeat you several times in a row, and you have to keep trying different methods until you finally break through. I'm talking about poppits today because they are one of those strings to your bow that you can use that clearly have loads of potential. So the key to working successfully with these children is for them to be working with a professional, namely you, who deeply understands all the early stages of learning maths that most children go through very early without the adults around them being aware of what those steps are. So in this video, I'm going to cover the oneness of one and the two-ness of two and the three-ness of three. I'm going to explore the instant recognition of small numbers up to 4, which we call perceptual subtilisation. I'll explain how we help children to develop instant recognition of specific patterns as numbers, which we call conceptual subtilisation. I'll talk about how children develop the conservation number, and then I'll explain how they develop an early understanding of addition and subtraction securely. When I've covered those topics, I'll explain a little more about how we help children move on to slightly harder topics, and a bit about some of the other issues that children who have particularly serious problems with learning maths may be experiencing and how we tackle them. Right, let's get started by exploring the nature of very small numbers. So the first question you need to ask is the child that you're working with able to tell you how many pops you've done when you've done 1, 2 or 3 if they are working slowly? It's tempting to assume they can, but you need to check. And as I've just shown you, you can check that quickly with your poppits. And it's a lovely place to start. Start with something that will build the confidence of most children. They will have had their confidence shredded often enough. Start easy. Now, if they can do that, you can move straight on to the next section. If they're struggling with that, then here's a link to a video which explains quite a few things you can do to help children develop that level of understanding. The next topic, which you can flow straight into, is perceptual subitization. Now, that is about children being able to instantly recognise up to 4 objects without having to count them. How many pops are there here? Most adults do not need to count 1, 2, 3, 4. If they do, there's a problem. The brain should be capable of processing up to 4 objects arranged in any way and instantly recognising the number of objects there are. So this is very similar to the last activity, but it's speeded up. How many? Just reveal them for a second, and the child should know. Now, the first step to ensuring that children who are struggling do become fluent at perceptual subtilisation is for the adult that they're working with to understand what it is that they need to be able to do. So you need to understand what perceptual subtilisation is and what it is you're trying to achieve with your children. The next step is just to work on it in different contexts, showing them different small numbers of objects arranged in random ways and seeing if that's enough to sort out the problem. Now you're both aware of it. Beyond that, I'm recommending Karen Wilding on Facebook because she runs training courses specifically on this topic, which are excellent. So perceptual subitization was about being able to quickly recognise small numbers of objects when there's no particular pattern to the way in which they appear. Conceptual subitization is about being able to instantly recognise specific patterns as being particular numbers, and it allows us to go well beyond the number 4 and instantly know numbers. How many pops? Well, that's a classic dice pattern, which is one of the patterns that most adults just know. And most children will quickly learn the dice patterns without adults having to work on it at all. But for children who are struggling, it can be a really tricky step, and it's definitely a step that you should be particularly aware of that they need to take and should be helping them with. And if you want to have some fun away from your poppets in doing that, then this is the game that I recommend, Ladybirds. It's great fun. And in that game, those dice patterns are on the cards and on the dice which you use. Now, conceptual subitization isn't just about dice patterns. It's also helpful to recognise the numicon patterns from 4, 5, 6, which is the same as the dice pattern, 7, 8, 9, and 10. But even more importantly than that, they need to be able to understand numbers to 20 as 5s and 1s. So with the poppets, you'd develop the first 5 like that, and then you would add in 6, 7, 8, 9, 10. So we're moving in columns instead of in pairs upwards. And this would be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we want to be able to hold up the poppet and for children to be able to spot that that's 12 without having to count the individual pops. And if you don't think that's a skill most adults have and most adults need, just look at this. How many lines are there? How many lines now? It's the same thing. It's there in the poppets, it's there in tallies, it's there in your fingers and toes, which you want to work on while working on that structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then your hands go next to your toes, and with your hands next to your toes, that would be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Sometimes you'll see me with my feet up on the shelf to demonstrate this, but I'm not feeling very flexible today. And it's the same structure that's here in my coat hanger and in other bits of maths apparatus like the Rec and Rec. But as I said at the beginning of this video, it's lovely to have a fresh way of working on these structures with the children who have experienced the most failure and who are likely to need a fresh start. Right, the next topic you need to check that children are secure with is the conservation of number. Now, the conservation of number is just the idea that when you move objects around, the number of them doesn't change. Most children learn it very young, but not all children. So you need to check that they've securely understood it, and you can do that with the poppet in a way that will consolidate their other learning. So how many pops there? Well, that's not clear at all. It's quite difficult to count. And although you could teach children to count it logically, working upwards in rows, it's still quite tricky. It's easiest to move the pops. So we could move this one down to here, this one to here, these two to here and here. And what I'm doing here is building them up into the 5s and 1s structure that children need to learn. So we've another 2 there that would go here and here. And there are 3 more over here that we could bring in here. And we have 9. So the poppet gives a great way of working on the conservation of number and the structure of 5s and 1s together with tasks that are appropriate for children who are struggling with number, that they are likely to enjoy and will do great things for them. Okay, let's talk about the journeys children take with addition. So classic addition would be 3 add 2. Now, most training courses and most textbooks talk about children starting by counting all, moving on to counting on from either number. So we might start with the 2 and count on 3, 4, 5, and then gradually learning to start with the larger number and count on 4, 5, because it's quicker to start with the larger number than the smaller number. Now that's a very logical way to think that children learn about addition, and it's a useful thing for teachers and adults working with children to know. But there's more to it than that, because the children who become really fluent in addition are usually seeing structure for their additions. So that brings us back to everything we've just done. The child who can use conceptual subitization to see that that's 5 can do that instantly. It's so easy for that child compared with the child who's not got that level of conceptual subitization. And as we work on to slightly larger calculations, take a calculation like 12 add 4, it's really useful to use the structure of 5s and 1s and see that 4 adding on like this. So we could see the structure of 12, we could see the 4 going on as a 3 and a 1, and we can see the final answer of 16. You're probably still using the strategy of counting on from the largest, so that's 12, 13, 14, 15, 16. That's absolutely fine, but you can see the structure to check your answer, and you should be able to teach a child that you're working with to do that too. And similarly with subtractions, we can start with very small numbers. If we take 5, subtract 2, being able to physically do it is lovely, and being able to count your answer is great. But it's even better to move on to using structure, because then we can take on much harder challenges like 17 subtract 3. 17 is there. Subtract the 3, working systematically backwards to take those 3 off the end of the 17, and we can see the 14. So when they're trying to count backwards, 17, 16, 15, 14, that's really hard to do, and they're likely to go wrong. And it's so powerful if they can see the structure of each number as they do that. So 17, 16, 15, 14. 16, 15, 14. Much better. Now, of course, you may be working with children who've already mastered these stages of development that I've just described, in which case I do have a couple of other videos on maths with poppits, which I'll post links to at the end of this video. They were designed for mainstream maths teaching, but if you've got a child who's just behind other year groups rather than struggling with the very foundations of maths, they're entirely appropriate. I would also say, as a next step on from this video, I have a series for adults working with children aged 7 to 11 who seriously struggle with maths. It's very short, and of course poppits aren't the whole answer, so it covers other structures that children need to access, like the bead strings. The other thing that I want to emphasize before leaving this video is that many of the children who struggle with the most serious challenges to learning maths also have physical problems which are making it really difficult for them to learn maths. So test these strategies with the children you're working with. If they start to fly with them, then physical barriers to learning probably are not an issue. They might once have been, but they're no longer an issue, and you're able to overcome that now. But if you think the child or children you're working with are still facing real barriers to learning easily, then here's a link to a video that I think you might find useful. My very final tip is that it's extremely stressful struggling with maths, and the original function of poppits was as a stress relieving toy, so they double up for that as well. And I would certainly let a child who's really struggled with their maths use them for that purpose too. I hope you've enjoyed this video and found it useful. If you have, if you've time to give us a like, to subscribe to the channel so you can find it again, to leave me a comment or a suggestion, or to share this video with your friends or colleagues who you think might find it useful, that would be absolutely fabulous. Thank you for the work you're doing to help to make every child a confident and creative mathematician, and thanks for putting the time in to work on your professional development. I hope to see you again soon for another video on how to teach primary maths. Bye for now.